Number 3, sketch the graph of f of x equals x cubed minus 3x squared using calculus. Domain is all x such that x is an element of the reals, all numbers. You can say it however you like. For b, we want to find the zeros, or the intercepts. So if I plug in 0 for x, I get 0 for y. If I plug in 0 for y, how do I solve a polynomial equaling 0? I should factor it. That's usually the best way if I can factor it. Set each factor equal to 0. Whoops. And solve. So I get 0 and 3. So those points would be 0, 0, which we already have, and 3, 0. C, there's no asymptotes. D, first derivative test. I set it equal to 0 and solve for my critical numbers. I'm going to factor again because it's a polynomial. If I pull out a 3x, I get 2x minus 3. No, that's not right. Ooh, I get 1x. Sorry. I get x minus 2. So I set each factor equal to 0 and solve. X equals 0, x equals 2. I test it out. If I plug in a negative 1 into the derivative, I get a negative times a negative. If I plug a 1 in, I get a negative times a positive. If I plug a 4 in, I get a positive times a positive. So f of x is increasing from negative infinity to 0, union 2 to infinity, decreasing 0 to 2, has a max at 0. I have to get the y value. We know it's 0 because I already knew 0, 0. Has a min at 2. I got to plug in 2 into the original. 2 cubed is 8. So f of 2 equals negative 4. Okay, so now we're going to move on to the second derivative test. So the second derivative is 6x minus 6. So if I set that equal to 0 and solve, I add 6 divided by 6, x equals 1. If I plug in 0, I get a negative. If I plug in 2, I get a positive. So f of x is concave down from negative infinity to 1, concave up from 1 to infinity, has a point of inflection at 1 when I plug 1 into the original. I get 1 minus 3, so I get negative 2. And now it's time to graph. I've got 1, negative 2 as a point of inflection. I've got 2, negative 4 as a minimum. I've got 0, 0 as a maximum. I've got 3, 0 as a 0. So I have a pretty good idea of what this thing does. It looks like it does that. I've got points everywhere I need, except I would need a point over here somewhere. So I'll say like negative 1. So I'm going to find the additional point of negative 1. So if I plug negative 1 into the original, I get negative 1 minus 3, so I get negative 4. And there's my graph. Let's see. I think I could probably get another one in here. Yeah, it's only been 5 minutes. I'm going to do another problem so I don't have to upload another one. Number 5. Find the point on the graph y equals the square root of x plus 1 closest to the point 3, 0. So x squared plus 1 is sort of looking like this. It's a very rough sketch, and there's 3, 0. We've got some point on the curve xy. Could be anywhere on the curve. We want to calculate that distance and make it a minimum. So the distance formula is the square root of x minus x squared plus y minus y squared. We just need to find the point that makes the radicand as small as possible. And that helps us find the derivative a little easier. So I plug in my points. I've got x minus 3, y minus 0. Then I have x and y in here, so I want to take the derivative, but I've got my two variables, x and y. So I'm going to make a substitution using my secondary equation for y. If I simplify that, I'm here. Now I can take the derivative, chain rule, and then power rule. So I set equal to 0. X equals 5/2. That's the x coordinate of the point that's closest. How do I get the y? I plug it back in here. So that would be 7/2. So the coordinates are 5/2 square root 7/2. That's the point that's closest. So, we might be able to do one more. Let me see what the next problem is. Find the relative extrema. Definitely. Let's get another one done on this video. 6. Find the relative extrema of f of x equals negative x to the 4th plus 2x cubed. F prime of x is negative 4x cubed plus 6x squared. I set it equal to 0, and I'm going to factor out a negative 2x squared. So I'm going to get a 2x minus 3. Just double checking that, okay? Set each factor equal to 0. Solve. Those are my critical values. So if I plug in a negative number into the derivative, I get a negative times a negative, I get a positive. If I plug in 1, I get a negative times a negative, another positive. If I plug in 3, I get a negative times a positive, that's a negative. They wanted the extrema. So there is a max, f of x, you should say f of x has a relative max at 3/2, and I have to get the y value. So I plug it into the original. Negative 3/2 to the 4th plus 2 times 3/2 cubed. So, what is that? 3 to 9, that's 81, I think, 3 to the 4th. 2 to the 4th, 16. Plus 3 cubed is 27. 2 cubed is 8. So I've got negative 81 over 16 plus 27 over 4, because that can cancel. If I get a common denominator, 27 times 4. 25 times 4 is 100. 2 times 4 is 8. 108. That's my guess. I'm going to stick to it. 108 minus 81. So let's see. That would be 19 plus 8. 27 over 16. That probably reduces, but I don't know, maybe not. I just don't feel like thinking about it. You can figure that out. Alright, I'll stop here and upload these.